Welcome to Computer Science 3200, the Intro to Artificial Intelligence course at MUN. So, my name is Dave Churchill. I'm a professor at Memorial University, and I'll be live streaming my lectures this year on Twitch, like I did last year. So, just for people who are sort of unfamiliar with unfamiliar with the way that this course works, is that officially from the university standpoint, this course is being offered via pre-recorded lectures, okay? So it's optional to tune in to the live lecture. Basically, what you're watching me do is you're watching me record the lecture. So for people who are watching this on YouTube, this is being live streamed on Twitch. So if you see me looking in this direction, that's me looking at the Twitch chat, glancing over to see if there's any questions and stuff like that. If I'm looking over this way, that's my other monitor where my files and stuff are, and looking straight ahead is where I'm reading the slides from. So hopefully that won't be too disorienting for you. So let's go over I have some slides here about like what is AI and stuff like that, but first let's get the course syllabus out of the way. So if you go to my website here, I'll paste that over in the chat. ~D Churchill is my name. This is the website, and you go to teaching. And last night I stayed up super late and redid this whole page, so it's super compact, a lot of information, not only about my courses but about the teaching and stuff. So here are my current courses for this term, which is fall 2021 to 2022. So I'm teaching 3 courses this year. COMP3200, which is the course that you are currently watching the first lecture of. That's algorithmic techniques for artificial intelligence. It's been called 3 different things over the years, so if it's called different things, sorry about that if it's confusing. I'm teaching 4300, which is Introduction to Game Programming in C++, and I'm also teaching Computer Science 6980, which is the graduate version of this course, okay? So Computer Science 3200 and Computer Science 6980, they will all have the exact same lectures and the exact same streams and videos for the course. The difference is that the graduate students' assignments will have extra things they have to do to get full marks, and the graduate students will have a final project in addition to the final exam. So the graduate version of the course, you've just got to go do a little bit of extra learning on your own that I'll assign you for the assignments and stuff. But both of these, all of these links for 6980 and 3200 go to the exact same thing. So let's look at the Google Sheet. So the Google Sheet is sort of the holy grail or the Bible for this course. If I open it up, let me zoom in here. So this tells you exactly what we're going to be doing in this course. It's the exact schedule. It's the links to download all of the lectures and the slides, etc. So for example, you can see first lecture is today, 0909. It's a Thursday. This is lecture number 1. And the lecture description is just Intro to AI. This is the intro to the course and the syllabus and a little bit about what AI is. If I quickly... let me blank out this screen for a second to show you what this will look like. All right, so I'm going to go to my previous course offering. All right, so this is a course offering from a previous year. So as we go through this year, this is the course website, or this is the spreadsheet for this course. This will eventually get filled out into all of these links like this, so that if you want to go back and see the slides for this particular lecture, you can go through and you can go through the slides. Or if you want to watch the video on YouTube for that lecture, it will be linked right there so you can go straight to it. Okay, so that's how this will end up filling out. There'll be more links and stuff here posted as we go, but this is essentially how it looks at the beginning because we don't have any lectures done yet. Excuse me. Also, the syllabus is here for the course. The syllabus is different for 3200 and 6980. Just because there's a difference in the marking scheme. And the links here don't go anywhere yet. They just go back to this page. Because there's no videos yet, the playlist hasn't been created. And so those links will become active at some point this evening once I get the first lectures up on YouTube and I get the playlist created and stuff. The link will be there. So, but if you're watching this on YouTube, that's already been created, so it's no problem. Okay, and as for people who may not be in the course, I just going to read this out. So I currently live stream all my lectures on my Twitch channel, which are freely available to for anyone to attend and view. Recordings of my lectures can also be viewed freely on my YouTube channel as playlists. I currently do not intentionally monetize any of my live streams or videos. However, some ads may appear which are inserted automatically by Twitch or YouTube. So if you clicked on this stream, unfortunately, an ad may have played. I'm sorry about that. I wish I could disable it. I have tried to disable it. I have emailed the Twitch affiliate program and said, please disable ads on my channel. And they said, no, that's how we make our money. So I'm just letting you know, I don't take a dime of that. It's like maybe I've made $3 in 2 years and I just leave it all there. So I'm not doing this for the money. Trust me. Lecture recordings will remain on my YouTube channel for 10 months after the start of a course. Then they will be removed so that next year's version of the course can replace them. So what that means is, for example, I did this last year as well, and there were playlists and videos and stuff on my YouTube channel, but all of those have been removed for this new version of the course. I don't want people skipping class just to go and watch the previous outdated lectures because they think they're the same. Right? And very importantly, while you are completely free to watch this course and view the lectures on YouTube, no course files or assignments will be distributed to anyone who is not a student enrolled in the course, due to the possibility of solutions being posted online. So I'm sorry if you really want to do the assignments, but I will not be giving them out to anyone who's not in the course. Because they immediately go up on Chegg and Russian websites that sell assignments, and they're on GitHub, and I have no way to take them down. And these assignments take a lot of time to make. So please, if you ask, it's just going to be a no. There's no circumstance in which I'll give you assignments if you're not in the course. You can see my fall 2021 live streaming schedule here. So if you click on this link, or if you go below where I am now and click on schedule, oh, got a little bit of echo there because my stream is playing in the background. You can see my schedule for all of my live streams for these courses. As I mentioned in my previous video for 4300, which is a different course, the live lectures for that class have moved, but this streaming schedule is, it's accurate, okay? You can import this into your Google Calendar if you want to, and if you do, all of this schedule should be in your local time zone, even though I've input it in my local time zone. Okay, so that schedule is completely accurate up until mid-December. I will be doing four streams per week for these classes. Okay, so just a little bit about the coloring scheme here. You can see all the topics that we'll be discussing on every day of the course. If it's colored blue, it means there's an assignment given out that day, so those are really important to watch. If it's colored green, it means that we have no lecture planned for that day. And if it's red, it's an exam, okay? So in this course, the really important thing is that there are in-person exams at the university on campus for this course. Now, I have been informed today that because the class is so big, I think I have 90 undergrads and close to 30 graduate students. The limit for taking an exam in a single room is 99 students on campus because of the health concerns with COVID and stuff. So when the midterm happens, there'll be two separate exams. One room will be for 3200 and one room will be for 6980. Whether or not it's two rooms next to each other at the same time or the same room one after another, we will see. But the important thing is that the midterm and the final will be on campus, because taking exams online was a nightmare and the cheating sucks. And no matter how much you tell people not to cheat, they are going to cheat if it's online. And I absolutely am completely against all these proctoring solutions that like watch you and videotape your computer. And so I don't want to ever do that. So you have to be in person to take this course. There have been a couple of people who have had visa issues because of the new, like the vaccine passport and stuff. And so a couple of people have had medical exemptions from the midterm. their midterm grade will be added to their final. But if it is physically possible for you to get to campus, then you are taking the midterm on campus. All right, and we've got a Remembrance Day, which there's no lecture, and the rest of them will be filled out as we go. Now, as you may have heard from the university, September 30th is a new holiday for Indigenous peoples, but it's for the whole university. It's an observance of that. And so September 30th is technically a holiday for the university. There will be no class that day. However, what the university did in their infinite wisdom was say, okay, there's a holiday on Thursday, so Thursday's classes will be on Saturday. I mean, what the hell? You're going to give us a holiday and then take it away? Like, anyway, I'm not going to get into all that. But what's going to happen is that the video will still be here on Thursday, okay? I'm still going to give it, and it's going to be here. You can choose to wait until Saturday if you want. It is completely optional to watch this on Thursday, all right? I'm getting my legal speak out here now. I will be doing it on Thursday just to get it done, but you can watch it whenever you want. This is completely optional. All right, so because officially the class is being given through pre-recorded lectures, we do not have officially a class on that day. All right, but I will happen to be recording the lecture at class time on that day. All right, got that out of the way. So just keep in mind about what September 30th is. Alrighty, so that's the class spreadsheet. Now back here, if you click on COMP3200, it will take you to this directory. That's just where I'm storing a few files. Okay, so for example, the syllabus is there. I just put that there so you have a link, but anything that will ever be stored in that directory will be linked from this spreadsheet. Okay, so if you want this, the syllabus, etc., it's right there. Also, you can see the MUN calendar. MUN is the name of our university. And if you look, oh, look. So the official university calendar doesn't even have that holiday in there yet. This was all done like 5 days ago. It's crazy. Anyway, I'll stop talking about that now. So that's what this is. The lecture links don't work yet. Oh, stay hydrated. So someone in the chat, I'm actually getting quite thirsty. All right. So these links don't work yet because we don't have any lectures there, but they will soon. So let's open up the syllabus for 3200 and we'll go through that. Okay, so here's the syllabus. We're going to go through the syllabus and then I do have some intro to the course slides after that. So this is Computer Science 3200, Algorithmic Techniques for Artificial Intelligence. I just call it Intro to AI because that's really what it is. Here's my university information. This is the course website, but there's not really anything there. So the objectives for this course is an introduction to AI covering techniques and data structures used in modern problem-solving environments. Each topic will have a related assignment where the learned techniques are applied to simple games. So we're going to be doing a lot of like game-type environments for our assignments for this course, which I think is pretty cool. So the course outline. First, today we're going to talk about what is AI, what can modern AI do, games as a testing environment for AI, agents, environments, and problems. That's the next lecture. We're going to go over search algorithms first. So the four main topics that we're going to be going over in this course are search algorithms, genetic algorithms or evolutionary algorithms, reinforcement learning, and neural networks. Okay, so that's what we're going to be doing in this course, and a very brief introduction to neural networks. We actually won't have an assignment on neural networks. So for search algorithms, we're going to be going over exhaustive search, so breadth first search and depth first search. And you might say, oh my God, I learned that in like year 1 or year 2 or whatever. But we will be going over breadth first search and depth first search in a way that you have probably not seen them before. And I really like going over these algorithms in this way because it ties it in to the next level of heuristic search algorithms. And it shows you how all of these algorithms are really tightly related. So don't skip the lecture just because you think you know BFS. I think it's going to be really interesting. Then we'll go into heuristic functions and incorporating knowledge into search. And then best first heuristic search, so best first search, A star. We're going to go over an introduction to some game theory. and Nash equilibrium. Nash equilibrium will point us in the direction of adversarial search, so minimax search algorithm with alpha beta pruning. And we'll go over some data structures and some optimizations for search, especially in the cases where we're using grids for search. Then we'll talk about genetic algorithms very, very briefly. There's an entire other course at the university for nature-inspired computing. We're going to introduce evolutionary algorithms. We'll talk about representations for GAs, and we'll do an implementation of genetic algorithms where we actually do a Sudoku solver with a genetic algorithm. Then we'll talk about reinforcement learning. So we'll do an introduction. We'll talk about agents, environments, actions, bandit problems, Markov decision processes, GPI, Monte Carlo methods, and we'll finish off with temporal difference learning and especially Q-learning, which is really, Q-learning is the stepping point into deep learning, which we're not covering into this course, but it'll be, it's such a huge algorithm. We'll be doing tabular Q-learning, and we'll have an assignment that we implement everything from scratch. Oh yeah, we're implementing everything from scratch in this course. We're not using any pre-existing algorithms or packages. We're doing everything from scratch. And then we'll talk about neural networks, because you can't not talk about neural networks these days. I'm going to go from the beginning of time up until what we currently know about some neural networks. So you will understand how neural networks work. We'll give a brief introduction to deep learning, and then that will set you on the path to later on, if you want to, you'll be able to learn more about deep learning. But we won't go super into deep learning in this course. We'll just learn what it is. So the textbooks for this course, for the first half of the course, for the search part, there's this excellent textbook called Artificial Intelligence, A Modern Approach, completely optional. Okay, I've put it there if you want to study on your own, because it's an excellent textbook, and a lot of the slides in this course are loosely based on that textbook. But I hate having students required to use the textbook. Okay, like I don't want you to go out and have to spend hundreds of dollars on a textbook. However, this textbook, Reinforcement Learning, is free online. Is this link still work? It does. So here's the book. All the full PDF and everything, that textbook is free online. So that's covering the second half of the course for the reinforcement learning stuff. So the format is that there's 2 lectures per week at this time on Tuesday and Thursday. They're 80 minutes each, or are they 90? No, 80 minutes each, yeah. And the lectures will be delivered remotely. So officially, I have to say again, officially, Twitch is not part of the course, okay? Officially, you have the pre-recorded lectures, which will be released maybe an hour or two after the live lecture, and that's officially, I know I keep saying officially, but it is officially the way that the course is being taken. So after this, what I do is I start the upload of the videos to YouTube, and I upload them, and then I put the links on the spreadsheet. So within usually 2 hours of giving the live recorded lecture, all the stuff will be online for the pre-recorded stuff. The lectures will be delivered remotely and recordings made available, and the midterm and final exam will be taken in person on the MUN campus. Okay. So for 3200, the evaluation of the course is as follows. So half of the course is going to be assignments, and half of the course is going to be exams. Excuse me, I got hiccups. So assignments will be done in up to 2 people per group. Okay, so find a partner, work with them for the assignments. The assignments are designed to be 2 people worth of work. So if you do them on your own, I have had students in the past do them on their own if you're a really strong programmer or really into this sort of thing, but I highly recommend finding a partner. I will be posting a link to a spreadsheet on D2L where if you don't know anyone in the class, you can post your name and email there and someone can contact you for a partner. When you go to submit your assignment, only one person submits the assignment, but we'll go into all that. So the first, let me first say that the assignments will be implemented in JavaScript and HTML. Now I know that using JavaScript seems a bit weird, but honestly, the point of this course is to learn the algorithms, right? This is not a super low-level optimization course. It's for you to learn the algorithms and implement the algorithms. And as we'll see in a bit, I'm going to show you some of the assignments. And the ability for me to do a user interface in HTML and CSS is just, it's beautiful. Like the assignments actually look really nice. In fact, you can see if I go to my website and then type /search, you can see like this is an interface that I did for the search algorithms in this course. And you can play around with this stuff here. And you can do things like, oh, let's animate the search algorithm so we can see exactly how the search is taking place, etc. So I'll post that in the chat if people want to play around with that while I'm doing this. Someone just asked, do we need to learn the languages on our own or will they be taught in the course? So we are using JavaScript for this course. Trust me when I say that all you need to know for JavaScript is the syntax for a function, for loops, declaring variables, and arrays. That's about it. Maybe a 2D array in JavaScript is the most complex thing you're going to see in this course. When I go over assignments, because my assignments, they're complicated, but they're complex, but they're not complicated, right? So I'm going to give you for each assignment a working user interface, a complete user interface like you just saw. And your job is going to be to edit one file, sometimes just one function, where you implement the algorithm on the back end, and then the user interface is going to use your back end code to actually run the algorithm. So I'll go over all of that, and you're a third year student by now. Just go look at like Intro to JavaScript online and the first like for loops, variables, arrays. That's all you're going to need to know. It's really not complicated. You're not implementing the user interfaces. You're just implementing the algorithms. And it'll be really simple. I'll give lots of pseudocode. I'll go over all that. So don't panic if you've never used JavaScript before. It's actually going to be way easier than you think to use it. Second assignment goes into A* search pathfinding. Then we're going to do minimax and alpha beta, then a genetic algorithm, and then some reinforcement learning. The midterm and the final, the midterm is worth 20%. You obviously do that by yourself. And the final exam is worth 30%. Now, something I do in all of my courses is that because 50% of the course is group work, I have had students come to me and tell me, hey, me and my partner alternated doing the assignments. My partner did assignment 1, I did assignment 2, they did assignment 3. I'm like, you got some balls on you to tell me that, first of all. But second of all, that I guess it's a glitch in the system, right? And so also one person can just carry someone else through the course. You know how group work goes sometimes. One person does more work than the other one. And so what I have is this caveat here at the end is that due to the group work nature of the course, to effectively show that you have individually learned the material, you must pass the final exam to pass the course. So if your grade on the final is less than 50, then your overall course grade will be equal to the mark that you received on the final. Okay? So please don't be scared by that. Last year, I had 4 people who failed the final, and they all got supplemental exams, okay? 3 of them ended up passing the supplemental exam, which was like, after the course was over. 1 person didn't show up for their supplemental exam. And I'm not talking about like getting a 49 or something like that. I'm not going to be that strict with it. But this is just so you actually show up and write the final exam, right? Because if people were going into the final with 70s, they wouldn't even show up. And so you have to pass the final to pass the course. Alrighty. I have to have a COVID notice here. The university said this. So the midterm and final exams for the course will be held online, in person, on campus. If any COVID-related issues arise during the term which requires MUN to close campus for students, the exams in this course will be moved online. Since lectures are being delivered remotely, they will not be affected by any COVID-related issues. So the only thing that could ever go wrong in this course, knock on wood, the only thing that could go wrong is if campus has to shut down due to COVID, I'll be giving the exams online, okay? And I had to go through this earlier, and I hate having to go through this again, but academic misconduct and cheating. Ask anyone who's taken a course with me. I take this very seriously. And I've been programming AI for almost as long as most of you have been alive. So trust me when I say that if you got an assignment done for you from someone outside this course, like if you paid to have it done or got a friend to do it, I can smell it. I can smell it. I know what I taught you, and I know the way that I taught you. And there are so many different, like if you Google an algorithm and you get the Wikipedia version or this Red Blob Games version, or I know where all the solutions are online, I've seen them all, and I can't tell you how many times I've looked at an assignment and I know the website that they copied it off of. So please don't try and cheat in this course. It's going to be very bad for you. Like fail the course instantly side of bad. I'm Liam Neeson when it comes to this stuff. And okay, so here's what constitutes cheating in this course, because apparently people still don't know. Handing in any material for evaluation that was done outside of you or your group. Okay, so if another group did something and you're handing it in, that's cheating. If you obtain solutions from any non-class source, such as people outside your group, previous course offerings, Stack Overflow, etc., that's cheating. However, for each of the assignments in this course, there will be like a prize for, it's just clout, but it's a prize. And I'll be announcing the fastest running solutions. And also we're going to have some competitions in the class. I do not want you obtaining solutions for the base functionality of assignments. So if I've said, do these 4 things, do those 4 things on your own. But if you go online and you want to get bonus marks, and you saw, hey, on Stack Overflow, they had this really cool transposition table for alpha beta search. And if you implement that and cite it in the comments, I'm completely fine with that. So you are allowed to get stuff online if it goes above and beyond for bonus marks, but not if it's the actual algorithm that I want you to implement. But you have to cite it, okay? All right. Sharing assignment or exam questions outside of the course for any reason, including sharing assignment sharing websites or online repos such as GitHub. So in the past, I have had assignments of mine show up on Chegg or these Russian websites that sell assignments. I've seen them on GitHub. They're searchable on GitHub. I have tracked down everything that I found on GitHub. I've found over 40 repos from previous students who've had code on GitHub, and I've gotten every single one of them taken down, either through asking nicely, asking again not so nicely, or DMCA takedowns. So I spend way too much of my time getting my stuff off of GitHub, but I do it. Now, that doesn't mean you can't use GitHub. I know people want to collaborate with their partners on GitHub. Just use a private repo, okay? So you make the repo private, you add them as a collaborator, done. You don't need to worry about it. If you want to make sure that your repo is private, go open up like Microsoft Edge or something where you're not logged in and go to your repo, and if it shows as private, then it's fine. Also, for one of the assignments, I will be giving out a solution, which is obfuscated JavaScript code, okay? Now I got a little story to tell you. Let me show you what obfuscated JavaScript code looks like. Let me open it up here. This is what it looks like. Okay? So this is the solution in obfuscated JavaScript code. I had one guy in one course send this back to his home country. That person de-obfuscated the JavaScript code, which takes an infinitely larger knowledge pool than just doing the assignment itself, and then handed in my decompiled solution to me. And didn't think that I'd know. Okay? So my obfuscated solution code, the actual code that I wrote before I obfuscated it, is written with a ton of super optimizations that you will eventually learn, but it's also written in this like hierarchical way with different classes, and none of that has anything to do with your assignment code. Okay. This person just sent it to their buddy, paid him $50, literally handed me back my code, and was like, here's my assignment. I can tell you that that person was no longer in the course and may have had very serious problems with the university higher up. Okay. So you might say there's memes in the chat right now about it being like a 5-head move. It's not. Like that guy may have had to leave the country for doing something like that. So please don't do that. And it's so much harder than just writing breadth first search. My God, like it blows my mind. What if some people put half the effort into doing the assignment that they do for cheating? Oh my God. All right. Then there's some policy stuff down here. Yeah, don't cheat. That's all I'm saying. Don't cheat. We'll catch you. And you won't learn it. And then you'll fail the final, right? So that would be bad. Okay. So that's it. That's the schedule for the course, or that's the syllabus for the course. The 6980 version, so the grad students out there, it's the exact same, except there's a final project. Okay, so the midterm is worth less, the final is worth less, and there's also a project, and we'll talk about that project at a later date. But that's the only difference between 3200 and 6980. Okay, if you go back here, technically, I don't have office hours scheduled, but if you really want to meet me on campus, I can. But like, I'm always online. So let me go into the slides here. I don't think I have anything on that. So there is a class Discord. Okay, there's a class Discord server. That is where probably 95% of the discussion and communication with me will happen during the term. There'll be nothing in there that's required for you to view. So the Discord server is optional, but it will help you. It probably will help you. What you can do in there is you can post anything you want. Like, does anyone need a partner for the assignments? Does anyone have a link to this video that he mentioned or that website? What does he mean by this in assignment 2? And you can answer all those things. Just do not post solution code. Okay. And I'm aware of the Discord servers where people share their goddamn solution code. I'm aware of those, and I have separate Discord accounts where I am monitoring some of those Discords. Okay? So that person over in the corner who's named something like a student, that's not them, that's me. All right? So I'm aware of some of those Discords. So don't think you're I've been cheating for longer than you've been alive, or fighting cheating. Please don't do that. All right. And also the assignments are just fun. They're actually pretty fun to do. Okay. So the Discord is private. It's for students. Please don't share that link. It is only for students. I see people joining the Discord now. And also, when you join the Discord server, right-click the server name and name yourself your actual name, because like there's nothing worse than getting an email like, sir, I was late submitting the assignment, and I go to see who it is, and it's like 420 Blaze It XX, right? Like, come on, I don't know who that is. So please just name yourself on the server what your actual name is. All right. Let's get into the lecture slides that I have. And we'll talk about what artificial intelligence actually is. So let me switch the scenes. There we go. That all works. I'll get my laser pointer up. Beautiful. Okay. I'll take a little hydration break here for a second. Alrighty. So we just spent about 30 minutes talking about all that, like the course intro. Now let's start talking about like, what is artificial intelligence? What are we actually going to be learning in this course? So what is AI? Some AI categories and examples, some applications of AI, etc. Quick note, there is no required textbook for this course. Oh, and also this kind of obvious by now, but whenever I say 3200, I also mean 6980. Okay, so it's the same course to me. It's just the students have to do different stuff. So there's no required textbook for 3200 or 6980. As such, the slides are designed to be study material. Okay. So typically I know that when you make a presentation, there's supposed to be more visuals, right? I actually have like the algorithms, a bunch of text and definitions of stuff in the slides because the slides are designed to be your study material for the exams. So as you go through the slides, you can read them, you can see all the algorithms, and so they're actually there. You should be able to do all of the assignments and study for the exams from the slides and from the lectures. So the class lectures, what I'm giving right now, they're going to be a mix of reading from the slides as well as other demos with a bunch of different visuals. So I might be doing some slides and then I'll load up the assignment or some, like I'll load up like Visual Studio Code and go through the code or the algorithms with you. And the slides are going to be linked on the course spreadsheet and they'll be given as PDFs. So if there's ever any animations in the slides, those won't be available in the PDF version, but you can watch the lecture recording if you want to watch those animations. So what is artificial intelligence? I mean, that's what the whole course is about, right? Believe it or not, it's not just Skynet. So what is intelligence? So academically speaking, I guess intelligence, I mean, you could write a PhD thesis on this, so I'm going to simplify things a little bit. But intelligence is some sort of capacity for like learning, reasoning, understanding, problem solving. Like you can look at something and tell that it's intelligent or not, right? Like dogs have some intelligence. Students have some intelligence. But does my phone have some intelligence, right? Like that's the question we're going to be looking at a little bit here. Artificial intelligence, to me, is building a program or a machine that appears intelligent to the user in some domain. Okay, so the appearance of intelligence. There's this other thing that's called strong AI or general AI, and that's the idea that eventually, if we get a general AI, that's a system that could be good at everything. Okay, we are not even close to that yet, not even in the same universe as being close to that yet, despite what all the companies and Elon Musk are going to tell you. So AI, John McCarthy, who was a extremely famous computer scientist. He developed Lisp, he won a Turing Award, and he coined the term AI. And his definition of AI was, it is the science and engineering of making intelligent machines, especially intelligent computer programs. It is related to the similar task of using computers to understand human intelligence, but AI does not have to confine itself to methods that are biologically observable. And I think that's extremely important. Some people, like, you know, if I asked my grandmother what is AI, she might say, you know, it's Skynet or something like that. Or it's a robot, but it doesn't have to be something. It doesn't have to be a robot walking around to be AI. It can be a recommending system on Netflix. That's AI, right? It could be something that plays rock, paper, scissors. That's AI. It could be technically, if you're talking about video game AI, it could be the if statement that controls a Goomba in Mario. That could be considered AI, right? So AI is kind of a poor term. AI should probably be like machine intelligence. There's another side of AI that's called computational intelligence. I really like that term as well. But the point is there's nothing really artificial about it. If something is intelligent, it's intelligent. And AI is essentially just computers that are intelligent. So artificial intelligence is the science of making computers do things that require intelligence when done by humans. So it's hard to lock down, right? Getting semantic satiation, as that's the term for when you keep saying a word over and over, it loses meaning. But intelligence, it's not, you can't lock it down, but use your human intuition of that. So as part of the field of study of AI, it's gotten so big these days, and this is only a small subset of what you would consider AI these days. But subfields within AI, you could have things like machine learning, natural language processing, speech processing, expert systems, planning, scheduling, and optimization, robotics, vision, And all of these have subcategories and subcategories and subcategories. And if you do like your PhD in AI, you'll be doing like something like a mile to the left of this. It's in such a subcategory and a subcategory. So for example, my PhD was in StarCraft AI, which was super fun. And I'll be talking about that maybe a little bit later in the course. So artificial intelligence is a huge field. And as I'm sure you're sick of by now, as sick as I am, is every company in the world claims that they're doing AI. I have had companies, local companies, come to me and say, Dave, we need AI, and we're not sure why, right? Like it's become such a buzzword that it's like hype now. But there is a formal definition. There's formal fields of AI study. So who knows who this is? Can anyone type in the chat who this person is? Alan Turing. There you go. Perfect. So Alan Turing posed the question, can machines think? Okay. Alan Turing's life was tragically cut too short by, I won't get into that, but abuses of government and society. So he wrote a paper called Computing Machinery and Intelligence. And in that paper, he said that definitions of machine and think are difficult, right? Like we just showed that. Like we tried to come up with a definition and it's difficult. So he said that the original question, can machines think, I believe to be too meaningless to deserve discussion. So he didn't think, like he said that term is so it's so abstract, it's so hard to define that let's instead pose this question as a game. And that was the imitation game, okay? So the imitation game, you have a computer, A, and a human, B, and you have a human interrogator, C. Can the interrogator determine which is the human and which is the computer? So essentially, the interrogator is going to ask questions to both A and B, and if they can tell after the answers have come back whether or not A is the computer or B is the computer, then that is the imitation game. And if you've never seen the movie The Imitation Game, go watch that movie. It's a good movie. Someone in the chat just said Blade Runner. Yep. So in Blade Runner, they were trying to tell, what was it called? Replicants, I think it was. Who were the robots and who weren't? They weren't really robots, but... So the standard interpretation of the imitation game is called the Turing test. Okay? So the Turing test is essentially, can computers exhibit behavior which is indistinguishable from humans in some domain? And so versions of this have been asked for centuries. Back in the 1600s, Descartes was asking this thing, and there were automata that could read and write. Like, oh my God, the automata they made were crazy. Diderot was talking about this when he's a philosopher, talking about parrots. Like, parrots can speak English, but are they intelligent, right? In 36, Ayer was talking about the consciousness of machines, etc. But one really famous experiment was called the Chinese room. Now, it doesn't have to be the Chinese room. It could be any language. I just like putting in these pictures here. But the Chinese room was proposed by John Searle in 1980. And what the Chinese room is essentially is there's a person inside a box. This is like a black box, okay? So the people outside the box don't know what's inside the box. Could be a person, could be a humor, could be a jaguar, right? A kettle, doesn't matter. So outside the box, there's an input and there's an output, okay? So the whole point here is that, and he called it the Chinese room because the Chinese room has different the Chinese languages have different symbols from English. So the whole point in here is that there's some input in one language. This person in here has a huge book that translates every word in that language or every symbol in that language to every symbol in the next language, okay? And so, for example, if we take the example here of translating like Mandarin Chinese to English, then what this person is doing is they're taking in symbols or words, looking up the translation in a book, finding the symbol in English, and throwing it out the output, okay? And the point here being that to the end users, this thing looks intelligent. The input is going in, the output is coming out, and the people think, oh wow, whoever is inside that room understands the Chinese language and can translate it into the English language. But it turns out the person in there has no idea that this is even a language. They're just looking at a symbol, going to the correct page in a book, finding the other symbol, and throwing it out, right? So what Searle was saying was that by looking up rules and performing translation, the person appears to know the language and they appear intelligent. But if you think about this, this is literally what a computer does. Every computer that has ever existed looks at symbols, looks in a big table, and then gets the next symbol and outputs it. Okay? So Searle is arguing that computers are merely applying rules to data. There is no human-like understanding of the semantics of actually what's going on. And so while Alan Turing posed that the Turing test is a test for intelligence, Searle argues that the Turing test is inadequate because even if it's indistinguishable from an intelligent source, is it really intelligent? Okay? So that's kind of the philosophy behind AI. My answer is, I don't know. Just do what your boss says, right? Like my boss said, teach this course, and your boss is going to say, write some AI that makes your game more addictive so we can get more microtransactions from 8-year-olds, right? Like that's what AI is such an overloaded term these days. Intelligence is, I don't know. I think of it as, can the system make a decision which has some logic behind it, right? Okay, so let's stop talking about the definition of AI, and instead, let's look at what AI can actually do in modern times, and that those modern applications of AI give a better sense of what AI is than like 100-year-old philosophy. Okay, so the first thing that AI can do, because this is sort of where my interest in AI lies, or one of them, is planning and scheduling. So if you've ever used Google Maps, you're using AI, right? So you've got a map. Underlying this map somewhere is a graph structure. You're going to point out a starting point and a destination. So for example, here I am going from Signal Hill to the Avalon Mall. Okay, and this is what it does. It runs a search algorithm. We will learn this algorithm in this class. Okay, you will be able to implement Google Maps once we're done in this class. So this is planning. There's also scheduling. So for example, we have all these courses at all these times in all these rooms. Make me a schedule such that none of the courses overlap, etc. So these algorithms are called planning and scheduling algorithms. They often use something called heuristic search, and we will be using heuristic search pretty extensively in this course. We also have autonomous control. So self-driving cars are already a thing. They're already safer than humans in most conditions. You know, you've got the Tesla autopilot and stuff like that, which are, you know, you see videos on YouTube of people asleep at the wheel of their car and stuff. So autonomous control, something AI can already do. Very interesting field of study. We've got image and pattern recognition. So for example, down here, we've got one of the oldest industrial uses of artificial intelligence, which is scanning numbers. So optical character recognition. And if you look at this here, this says lunette. This is not French. Well, it kind of is. But the le in lunette is Yann LeCun, who is currently the head of Facebook AI research. And he did a lot of early work in neural networks for recognizing and convolutional neural networks for recognizing characters. So every single letter that you've sent, I don't know, do people send letters anymore? I maybe send like one letter every 2 years when I'm returning an Amazon package or something. But when you write an address, that has been optically character recognized since like the late 70s or something, or early 80s. Also, you have facial recognition. It is my opinion that facial recognition technology is one of the most evil technologies ever created and will lead to a lot of bad things. But hey, you can unlock your phone, which is kind of convenient because the fingerprint scanner is so hard to use. Facial recognition technology is horrendous, but it's there and people use it. So yeah. It's also used for some really bad stuff these days, but I'm not going to get political. All right. Healthcare. AI is becoming more and more a part of healthcare. So, for example, right now we have telesurgery. So that's becoming a huge thing. That's more of a robotics problem than it is an AI problem. But you can do surgery remotely and stuff, and robots can get their little tweezers in places that you can't fit your hands, etc. Also, deep neural networks have been used for the last decade or so for looking at like brain scan or like tumors and stuff like that. So if you're unaware, the way that the medical industry works, when you go to get like a scan done of like a brain tumor or something like that. Now, you know, I might not be 100% correct with this, but this is what I've heard, is you go in and you get the scan, right? Now, the doctor is going to make a diagnosis of your health based on two things. The initial scan, like where the tumors are and the size of them. And then as the months go by, they're going to do more and more scans, and they're going to see the new positions and the new sizes of the tumors. So if the tumors have been in the same place and they're not growing for like years and years, maybe you're fine. But if the tumors are rapidly spreading and rapidly getting bigger, then you have a problem, right? So the way this has been done traditionally is they have specialists who get the images, then they're given to humans who get these packages of thousands of these things, and their job is to sit down and trace where they think the tumor is on an actual piece of paper, okay? And then they color it in, and they try and like make an estimate of the size of the coloring, and then they say, okay, the tumor was like 10 centimeters squared, but now it's 15 centimeters squared. Turns out AI is way better than humans at this. And so this is one of those sort of grunt work jobs that AI should replace and does a better job at. And so that is like becoming more and more popular in the healthcare field. Also, we have robotics. So we have over here is an example of swarm robotics. So in robotics, there's two main branches that you can separate the fields of robotic research into. One is like, this is an example of swarm robotics in which you have many simple robots working together to accomplish a complex task, or you have one larger, very complex robot. So more of the Boston Dynamics sort of thing, right? So here we have some guy from Boston Dynamics making sure that Skynet is going to go ahead, right, by teasing the robots. And over here we have like a bunch of really small robots operating on very simple rules, but can form shapes that look like humans and stuff like that. Actually, some of my research and some of Dr. Vardy's research in the department are also on swarm robotics. We also have musical composition. So this is just kind of a meme image here. So this is a robotic band that plays music, but there are entire conferences devoted to AI that creates music. And studies are showing that like classical music and pop music, like choruses and stuff that are currently being generated by AI are indistinguishable from human generated music. Like they're really, really good. And I'm really excited about this because I think that like dynamically generated music is like the future of video games. You know, like based on what you're doing, the music gets faster or changes tone or something like that would be really cool. Musical composition is a huge field. Art is also a huge field. So if you thought that AI is only coming for your job if you're like data entry, no. So Google Deep Dream is this like nightmare fuel, deep convolutional neural networks for combining images. Over here, this is something called style transfer, where you can take a bunch of images in the style of one person, so say Picasso or Van Gogh or something like that, and then you take a video and it can style the video in the style of the artist you gave it. Now, 4 years ago, when I started giving these lectures, people were like, oh, haha, that's not a thing. And now you can do that on your phone. Like, did anyone ever see that Wombo AI that like you put in a picture of yourself and it makes you sing like Aretha Franklin or something like that? Like, crazy. It's on your phone now. That's how prevalent this is. Also, procedural content generation for video games. Like here's an algorithm that's making a maze or a dungeon for a video game. If you're really interested in more AI for games specifically, next term in the winter, I'm offering Computer Science 4303, and that is AI for video games. So we cover stuff like this in that class, but but we're not doing it in this class. Also, language processing and translation. This stuff is incredible. If you've never used the Google Translate via photos option on your phone, it's incredible. Like, this is not like pre-rendered. This is something that actually happens. I went to, where was I? I was at a sushi restaurant who had half the menu in Japanese and half the menu in English, and I pointed my phone at the Japanese side, and it translated it in real time. Like, mind-blowing, even just like 10 years ago. But obviously, sometimes there are funny, mess-ups with the translation stuff. It's not perfect, but it's enough that it's like possible to get by in a foreign country without speaking the language. And obviously take over the world, right? So that's coming soon. All right. Had to take some drink of water there. Game playing. Game playing is the new hotness when it comes to AI. At the end of the course, once we've learned what heuristic search is and we've learned what deep learning is, we're going to watch the AlphaGo movie. And there'll be questions about AlphaGo on the final exam. And so Go is this board game from Eastern Asia that's been thought to be sort of, the human's last stand against computers. But turns out that computers are already way better at humans at Go. Like, in the 5 years that I've been giving this talk, everything's changed so much in just 5 years. Also, there's video games. So my field of research is in StarCraft AI and video game AI. And so, computers still haven't beaten the world's best humans at StarCraft. Even though AlphaStar is very strong, it has not beaten the world champions yet in any sort of meaningful way. Okay, so that's what AI can do. How do we make new AI? So, all of this stuff just doesn't come from nowhere. You're not out flying a kite like Benjamin Franklin and invent electricity, right? Like, how do we make new AI? So AI research and development has a process to it, okay? So first what we do is we identify a problem that we want to solve or a new area that we want to work in. So for example, I want self-driving cars, okay? Then what we're going to do is we're going to go out and we're going to review the literature of existing techniques. So I want self-driving cars. Step one is, has anyone already made self-driving cars? Let me go look at that, right? I have seen people, PhD students, do 3 years of work and then throw it all away because they found a paper from 1987 that did what they did, right? You gotta go look at the review, like the literature, and see what's out there. Unless you're something like a modern video game company, in which case you just copy other games and make billions of dollars. All right. After you've done your lit review, you develop new techniques, okay? And so that's sort of where the magic happens. Then you test those new techniques against the state of the art, so the current techniques, under specifically controlled circumstances, and then you apply the new techniques to the problem. So this is sort of the step, the iterative thing that we do. So how do we test new AI? Well, one way is to play games, because games measure intelligence. If you think about it, it's really difficult. Like, we just tried to define intelligence at the beginning of the lecture, and you saw how hard that was, right? So how would you come up with an algorithm to measure the intelligence of a system? It's like impossible. You can't measure intelligence. So what we're going to do is we're going to take our new AI method and have it play a game like chess or Go or StarCraft. And if one method beats the other method at that game, then it's probably smarter, right? And the cool thing is, in my opinion, everything is a game. This course is a game. University is a game. Your job is a game. You're fighting your boss for more money. They're fighting you to do more work. Relationships are a game. You're looking for the most attractive person to you. They're looking for the most attractive person to them. Maybe someone else comes along. Maybe you get left for somebody. I don't know. You've got to see what you like. Like everything, life is a game. And why is life a game? Well, what is a game? You've got an agent in an environment, right? Agents can take actions. You're an agent taking actions. Actions affect the environment. If I go hit somebody, they're going to hit me back. That's affecting the environment. The agent has a goal, whether that's defeat the opponent, move to the right, solve the puzzle, get the more points. have the most partners, make the most money, be the happiest, right? Those are things that people look for in life. And so everything's a game. It's just that some games are more serious than others, right? Some games have actual consequences. Like a game of chess isn't so bad unless you're maybe the world champion and it's your job. But like something like search and rescue, even though it is a game, you have a time limit. You're trying to rescue the most people. You're trying to get that high score. If you fail at search and rescue, the consequences are extremely dire, right? So AI in games. Games can simulate the real world. And so game AI success can translate into real world success. Another really important thing for research purposes is that no ethics are required for games. If you're not familiar with academic research, if you do any sort of research that has to do with the real world or animals or the environment or people, you've got to go out and go through like a review process that could take months or years. You've got to convince people that you'll be like fine. And so let's say you're trying to make a self-driving car, right? Would you rather test your self-driving system in like Grand Theft Auto or go straight to the road, right? So you don't need ethics required for games because games, you can destroy all the entities in a video game that you want and no one's coming to you for ethics approval. Games are also cheap, even though, there's not a Steam sale on every game, but in comparison to like $1 million robot or like a car that you might crash or the stock market or something like that, video games are quite cheap in order to test your AI. They're easy to visualize. They're intuitive. They're fun to program and play. And ideally, they help motivate people to learn. Okay. So human versus machine has been a huge motivator for the development of AI over the years. And so when I gave this talk originally, like 10 years ago, Go wasn't even close to beating humans. But now it's infinitely better than humans. StarCraft, still kind of iffy, Also, even if we don't care about the real world, video game sales are like hundreds of billions of dollar industry. So if you make the AI better, you make the game better, you sell more games, economy is also a big motivator. What can AI do for games? Well, you can have more intelligent NPCs in your game. You could have better single player experience. You can create offline tools. Those tools can be used for game balancing or to reduce human testing. And you can apply it to other areas of games as well. And so what we're going to do in this course is we're going to teach the AI algorithms, and then the assignments are going to be like video game environments that we apply our algorithms to. Because we don't need to go out into the real world. They're really easy to visualize and make intuitive connections and stuff like that. What about AI at MUN? So what is currently going on at MUN in terms of AI? Well, there's a lot of stuff going on at MUN. It's like there's been funding. Like, for example, my research at MUN, for my lab, I've had money from ACOA and DeepMind and Facebook and InnovateNL. Lots of cool people giving money for research. This is like my old lab. This is Lucas, Rick, and Rory and Caroline. They all did research. So 2 of my students graduated. They're doing their PhD. Other people are also going out into the video game industry or like machine learning and industry and stuff like that. Some of those projects, well, we hold the StarCraft AI competition every year at MUN in October. So right now, if you go to my website, you can find a link to the StarCraft AI competition. So the StarCraft AI competition, the AIIDE competition, that should be to 2020. So I have organized that competition for the last decade now. We've been holding it at MUN since 2016. There are 2 other international competitions and a bunch of other smaller competitions that have propped up in recent years in which people write AI programs to play StarCraft and then the bots play against each other. Hugely international thing. Lots of different countries compete. And we get like funding from different companies for that. Not enough funding. Maybe I hope they could give us more. But no, the competitions did not stop. They're still going. I just have not updated these slides in 2 years, so I apologize for that. Okay. Another thing that I do for my research is autonomous robotics. So one thing I did was reinforcement learning for pattern formation. So what I did for that one was we wrote this physics simulator, and we are going to learn stuff similar to this in this course this year. We may not get this advanced, but we wrote like a particle simulator, and then on top of that particle simulator, which does all the physics, so all this is from scratch. Oh, sorry. Yeah, we're not going to be learning that in this course. Maybe in 4300 we'll learn. So my game programming course will learn some of that. Sorry. It all gets jumbled up in my head. So what we did was we wrote a reinforcement learning algorithm that learns to make certain patterns by pushing these objects around in a virtual space. So here we're trying to make like donut shapes, and the reinforcement learning agent, which only has 16 bytes of memory. Okay, so this is not deep learning. This is like shallow learning, is able to make these shapes that we want them to make. I also do research in real-time strategy games for like combat. So real-time combat is a very difficult problem. So we've written simulators that simulate StarCraft. There's a machine learning environment for StarCraft now, for StarCraft 2, that Blizzard and Google released. So you can use using TensorFlow from Google and StarCraft 2 engine, you can actually use reinforcement learning for StarCraft 2 right out of the box. And this is how AlphaStar was written. I also do AI for video game development and design. So things like procedural content generation. One of my students, Sean, is working on genetic algorithms for level creation, stuff like this. And we also have a bunch of courses at MUN which are related to specifically either AI or video games. So we've got 3200, which is this course, 3201, which is nature-inspired computing. We've got Intro to Machine Learning. Both of these are excellent courses. I highly recommend you go take those. And then there's two other of my courses. So 4300, which is Intro to Game Programming. I'm teaching that one. And you can see that in the schedule here on Twitch or on YouTube. And 4303 is offered in the winter, so in January, that course will start, and that's all about AI and computer games. Cool. So we can shut that down. I'll go back here. And so that is the intro lecture to this course, and I am going to have a lot of fun with it. I'm going to stick around, and I'm going to answer a few questions before I end the stream now. So someone asked, do the StarCraft simulators have the same movement bugs as the game? Not these. These simulators don't. And it looks like that may have been the only question. Okay, so that was the only question. So I'm going to stop the recording there. And since it's the first lecture, someone asked, any recommended JavaScript IDE? Yeah, sure, I can show you one right now. So what I use, so for example here, this is like assignment 2 in the course. I know this is a little bit small, but I highly recommend Visual Studio Code. So Visual Studio is not Visual Studio Code. So Visual Studio is a huge multi-gigabyte program that has a compiler for like C#, C++, all this kind of stuff. Do not use Visual Studio for JavaScript. Use Visual Studio Code, which is still an IDE, but it's much, much smaller. So for example, if I open this folder in Visual Studio Code, you can see over here, I'm not going to open the solution code. I can open the obfuscated solution code. I can open the student code. And then all you'll have to do is you won't need any IDE. You could take this course in Notepad if you want to. I don't recommend it. Notepad++ is also a great program, or you can use Vim or whatever. And because this is JavaScript and HTML, all you'll have to do is open up the HTML file, and once you hit save in the JavaScript, you just hit refresh in the HTML, okay? So it's super easy. There's very few requirements to taking this course. Just having a web browser, basically, is it. All right, so, and I'll get into more of that once we start introducing the assignments in a couple of lectures. So someone else asked a question, which I answered at the beginning. Can non-MUN students download the course material that is in PDF? So no, people who are not registered for the course, they are free to attend the live lectures and watch the recordings, but none of the files for the course including the slides and the assignments will be available to non-students. And that's just to protect the course. Do we need to form the group at the start of each assignment? What I recommend is just finding one partner that you like to form your group and using them for every assignment. Okay. All right, well, thanks a lot for tuning into the first lecture, and I'll see you at the same time on Tuesday.